a repeated pattern at regular intervals in our time
Okay,
series
okay,
data. So that's what I see
okay.
as seasonality.
All right, sir. So, Sister Ayedun, is it Mrs. Ayedun or Mr. Ayedun? Tominsin wants to say something, so you can just unmute and say whatever it is you want to say.
Okay,
So you can go
seasonality
ahead.
is
Yes.
an known period. So they are always
Okay.
regular and repetitive.
All right. Beautiful.
Always
Beautiful.
at
So we say,
time.
okay. So constant seasonal period, that is the length of our seasonal repetition cycle must be known and fixed. How we follow? You know, we mentioned something like cycle and seasonal. You know, when Prof was reaffirming that they are not the same thing, they are quite different. Exactly, good. That is, we have some kind of peaks and troughs in our data sets, but they don't repeatedly happen. They are not seasonal. Are we getting that? They don't have a continuous pattern. So in ARIMA model, it has an assumption that the length of the seasonal repetition must be constant. If our seasonality is by 6 months, what is going to be the declaration of our seasonal variable? Can somebody just say it's fast? So when I say the seasonality of my data set is 6 months, what is going to be the value of
6.
who is talking? Mrs. Ayedun or Miss Ayedun, do you want to say something too? Eh?
Yeah, I said 6.
Okay. Okay, thank you very much. Beautiful, beautiful. So now we are going into our data, we are going into our process. So I just wanted to lay those foundations so as for us to know and not to be strange to some of the things we'll be doing in the course of this session. So you know, when we mentioned something that when you're trying to do anything in data science, in data analysis, there is something that is important for you to do first. You know, it's just like someone that is going for war. It is important for you to go with you go, hello, please, who is, please help me mute that person that is disturbing us. So when we are going for war or we are going for anything, the first thing you do is to get your artilleries and pick everything which you need that will be useful for this battle. You need to keep them. If you are going for lectures, you need to go with your notepad and your pens. But now we are going for a battle of data analysis, data science. So what are the things we need to do first? The first thing we need to do is to import our libraries, right? That is every library which is going to make life easy for us during the coding process. We need to bring these guys, we need to call them because we are going to be getting a lot of things from them. So the first library which we are going to be we're using is the forecast. The forecast is what, you know, in time series, you said what we are doing majorly is trying to forecast what is going to happen in the future based on what has happened before. So we talked about the T series. Our T series is a powerful library that we use in time series analysis in R. Then metrics is, you know, when you build a model, before you can say, you can certify the fact that this model is good or bad, it needs to go through some scrutiny or some evaluation. So we're going to be getting every of our evaluation metrics from the library metrics. Are we following? If you are following, I want you to unmute and say you are following. If you are
I'm
following,
following.
unmute and say you are following. All
I'm
right,
Yes,
all
following.
sir, we
right,
are
We are
all
following.
right,
following.
We
all
are
right, all
following.
right. Beautiful, beautiful, beautiful.
Following,
So,
following.
so for this session, we are going to be using an inbuilt data set. We have so many inbuilt data sets in R. So we are just going to be picking one of them, which is the air passenger data. The air passenger data is an inbuilt data set that we have in R programming language. We have so many data sets in R. We have like the high-risk data too. We have many data sets in R. But we are just, for the sake of this study, we are going to be using the air passenger data because it is the data set that it is talking about the number of passengers over a period of time. over a period of time. So we are going to be using that data. So that is this line of code, the data, then in open and close parentheses, then in quotes, air passengers. Then if you run this, that is, you have called the data from R. I believe we are running the code. We need to run the codes. We need to run the codes. If you have not installed any package, you need internet to install all of these packages. So if you're having issues calling your library, the first line of code, the required library, that first 3 lines, from line 14 to line 16, you will need internet to run all of this if you don't have them installed in your R studio. So you need internet. So if you're having issues, if these guys are not installed, there is no way you can call the libraries. You need to install the packages before you can call the libraries. I have installed the packages. That is why I can now call these libraries now. So now I bring in my data sets. What I said my data set is air passenger data. Air passenger. So I run it. Then after doing that, I give my my data, I give it an assign. I assign it to air passenger underscore data. So I check the summary. You know, we mentioned something that when you're trying to do something, we need to check through our data sets to know what is happening in our data set. So the first thing we are going to be doing, which is very, very important, is to check the summary of our data sets. So I'll run that now. So in the summary of our data set, it's telling me that the minimum value in my data set is what? 104. Are we following? Are we following?
Yes,
Are we
sir.
following? The
Yes,
minimum
sir.
value in my data set is 1/4. So if I ask you now, 75% of my data sets, where are they? What is the value? 75% of the observation in my data set are under which? What is the value? The 75% of my data sets.
Third quadrant.
Yes, what is
Third
the value?
quadrant.
What is the value? What is the value? There's a
360.
value there. 360. Beautiful.
360.5.
360. 360.5. Thank you very much. So my maximum value is 622. My minimum value, the first quartile, that is 25% of my data set. It is also the same thing as the 1/4 quartile of my data set. It is around 180, right? So I check the first few
Yes.
rows. How do we check the first few rows of our data sets? We use the head function in R, which is an inbuilt function in R, which is used for explorative data analysis. So we check the head function. We check the head of our data sets. So this is the first 5 observations of our data sets because it is a time series data set. Do we remember that? It is a what?
Time
It
series
is an
data.
observation that is happening over a period of time. So then I want to rename my data set now because we want to start the process now. So I'm going to be renaming my data set as air underscore data, which is also air passenger data. So I am overwriting air passenger. You know, I've assigned my data here initially as air passenger underscore data equals to air passengers data, air passenger. So I am now overwriting it now. I'm calling it air underscore data. So I am running that. So I am going to be plotting my data sets right now. Okay, let me do this. Let me plot into the bracket of air underscore data, right? Then type equals hell. So yeah, this is my data set, right? Can we see it? Can we see it? Can we see what I posted?
Yes, sir.
Yes, we can.
Okay, so all right, so there's no need of changing the color then, since we can see it very well. Okay, so now we can see that this is my data set. And you remember, we mentioned something, we laid some foundations at the beginning of our work that we need to be sure that our data set is not having a varying mean or variance over the time. So the first thing we are going to be doing is to stabilize our data set. You know, we mentioned something the other time that we need to, during some of our mock-up session, that we're talking about the fact that when we get our data sets, we need to bring it to a balanced scale. So we talked about normalizing our data sets, or we say we standardize our data sets using so many things. We use the min-max rule, or we use the z-score, or we use so anything of our choice. So the first thing now we are going to be doing here is that we are going to be transforming our data sets. We are going to be transforming the data sets, right? So we transform our data set by transforming our data set. We are using the logarithmic transformation. We can decide to use standard deviation as well, but for the course of this study, we are going to be using log transformation to make sure the variance in our data sets is stable, because it is one of the assumptions of our model. So these are our model assume all of these things are in place. So because this model assumes all of these things are in place, so we need to mimic our data set to satisfy all of these assumptions. We need to bring our data set to a point whereby it is satisfying all of these assumptions one after the other. So variance balance, after we run this thing, we say it is what? Checked. What did I say? What did I say? You can unmute and say it.
It's
Checked.
checked.
Say checked. Checked. Yes. So
Checked.
yes. So we are making sure our variance is checked. So we do that. You can see, is there a difference between this plot and the initial plot? Is there a difference between this plot and the initial plot?
Yes, sir.
Is there a difference? What's the difference? Who can tell us the difference? Who can tell us the difference?
The difference, hi, sir. Hi.
Yes, sir. Go ahead,
The
sir.
difference is
Go ahead,
that
sir.
the second one has been logged, but the
Thank
first
you,
one
sir.
was not been logged.
Thank you very much, sir. Thank you very much. Thank you. You can see the y-axis. You can see the values we have there. It shows we've transformed the data set. So our observations, our y-axis values has changed. And you can see our data sets too. Our plot has changed. You can see the trajectory for the first is quite different from that. What it's telling you is that if you pick a particular window, that is, if you pick from this particular window to this particular window and check the variance, it is going to give you the same value as checking another window of our data set. So that means we've checked the issue of variance balance. We've done that already. So now we need to convert our data set to a time series data set. So that is what this function, you can see this TS that we have here. This thing I've highlighted. It is a very, very powerful thing whereby it is making sure our data set is transformed into, it is converted into time series. Mr. Adini, you can go ahead.
Please, I want to ask that what informs us to know that we have to log this? Why can't we do another method of transformation? Why do you need to log? Why do you use log in this case?
We can decide to use any method. There is actually no, you can decide to use, that's what I mentioned when we were transforming, that you can decide to use the standard deviation to log transform, but we're only using log transformation method. We're only picking one method from so many methods we have. Is that clear, sir?
Yes, sir. Yes, sir. Noted, sir. Thank you.
Okay, so now we are going to be changing our data set to a time series data set, right? So then this is our data set, a log transform data set. You know our data set is air data. So when I'm mentioning our data set, just mean no, I am talking about the air data. Then it is going to be starting from 1949. This is a what? Based on what Mr. Sam has been teaching us in HAR, what is this called? This thing I'm highlighting, what is it called? What is it called? Anybody? Anybody? I want
Concatenation.
an excellent student. No,
Concatenation.
yes, it's concatenation. But
Combine.
what kind of data type is it?
A
This is a
list.
vector.
What's the data type? Yeah, who said vector?
This is a vector. I didn't need.
Yeah, very good, very good. An excellent student. That's very, very good. This is a vector, so we are concatenating it, we are joining it. That is starting from 1949, comma, the first month of the year. And the frequency is 12, meaning we are working with a 12 calendar month. So the next thing now is to, we mentioned something that our data sets must have a balanced mean. Our mean also must not change over time. So now to address that, we are going to be using what we call the augmented decupula test. You could remember, if you could remember vividly, the facilitator last week mentioned augmented decupula test, how that it is used to check if our data set is stationary. So this is the judgment of our augmented decupula test, which I've highlighted. I have given us here as a markdown here. So we can see now, we say if our p-value, so in the augmented decupula test, what you're actually working with is our p-value. So if our p-value is greater than 0.05, we accept the null hypothesis, right? That is to tell us that it is giving us an information that our data set is not stationary. That is what happens that, so if our data set is not stationary, what do? We do something called differencing. We do something called differencing. That is, we subtract we subtract from the present, from the direct observation that is coming before it. So we try to, so if you need to difference your data so many times, so if you do the first differencing and your data is not stationary, what do you do again? If you difference once and your data set is not stationary, what do you do again? What do you do again? Anybody? What do you do? If I difference my data set and it has really not still satisfied my assumption of a balance of a mean that does not change over time, what do I continue to do? Let's talk so I can know, so I know we are following.
We transform it.
Difference again. We'll difference again.
Difference again until you get your what you want, until you get what you want.
That's actually what it is, but I don't want to confuse people. That's why I use it. Yeah, all right. So we continue differencing. Our data set. So we run this now. So we can see now, if you see in our console, see this thing I am trying to highlight here. It is the decupula test. You can see the p-value here. Our p-value is 0.01. So since our p-value is 0.01, is it greater than or less than 0.05? Is it greater than 0.05 or less? Eh?
Less than.
Less than.
So it's less than 0. So what does that tell us? Thank you very much. Thank you. We are following. Thank you very much. So it shows me we are following us very well. So we've certified the fact that our data set is stationary and the variance does not change over time, right? So
Yes,
what
sir.
we now do now, what we need to do now is to plot. I think I've overplotted my data set safe. So now what we do now, we said something also that we need to decompose our data sets, because what we see of our data set, what we see in the plot is not all that we have therein. So we need to do a proper check of our data set. So when I say I am trying to decompose something, what am I trying to do? When I say I am decomposing, what do I mean I'm doing then? If I say I am decomposing my data sets, yes?
To
We are
break
trying to
it
make it
down.
more
separating it.
Yeah, we are breaking it into
Right.
chunks. We are breaking it into pieces because we want it to be in chunks. When you want to cut your meat, you cut it into sizes because so that it can ease the rate at which you hit them. So you are not eating big chunks. So we want to break our data into different chunks. So what do we use? We use the STL decomposition. So STL decomposition. So we plot our STL decomposition. So this is the line of code for our STL decomposition. So we plot our decomposition so we can see what has happened in our data set, how that we have decomposed our data set. So yes, I run it. Let's come to the to this place where my arrow is, where we have the visualization. You can see I have decomposed my data into how many? Into how many?
1, 2, 3, 4.
4 plots.
4.
Into 4.
Yes. My data has been decomposed into 4, but actually the decomposition is into 3. It is not into 4. Because the first one is
Exactly.
just talking about my data sets. Right?
Yes, sir.
Are we following? Yeah. So I
Yes,
have the
yes, sir.
seasonal, I have the trend, I have the remainder. You will see some bars. Are we seeing some bars that are at the end of each box? Are we seeing some
Yes.
bars? Are we seeing
Yes.
those bars? The shorter the bar, the more important that decomposition is, the more big the information of that decomposition to our data. The more relevant, let me put it that way, the decomposition is in our data sets. You will see trend. You can see trend is very short, right?
Mm.
Yes, sir.
We can see trend is very short. So what is that? What does that tell us? What does that tell us?
It's not important.
Yes, not
No,
so relevant.
It's telling
no.
that the trend is very much important too.
Yes,
We
because
It
should
is
just,
what? It is
it's very
very,
much
very
important.
important. Yeah. What can we say about this data set? You can see that our data set is really trendy. You can see
Yes, yes.
that is our data set has highs and higher highs. You can see this is a high and this is another higher high. 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 So that is what our data is. So it is telling us that our data is highly trendy. You can see the seasonal decomposition as well. What is it telling us as well? What is it telling
It's
us?
telling, it's telling that it is less important, or unlike the trend.
Yeah, but we have some level of seasonality in our data set.
Yeah, it has like three peaks.
Yeah, so our data set is highly seasonal too. It is highly seasonal, but if you talk about the remainder is very, very long. That is, our data has a very minimal amount of noise, right?
Yes,
Are we
sir.
following? Our data
Yes.
set has a very, very minimal amount of noise. So the next thing we do is that we split our data sets. We split our data set. So we have some portion of our data set that we use to train our ARIMA model, and we have another portion we use to do what? To test our model. Are we following?
Yes.
Are we following?
Yes,
So
sir.
first thing first, let us check the length of our data set. Who can tell us the length of our data set? What's the length of our data set? What's the length of
144.
144.
144,
6
right? 144.
Yes,
The
sir.
length of our data set is 144. Now that we know the length of our data set is 144, so we want to split our data set. We want to use the 80-20 split, right?
Okay.
80-20 split. So now, my number of train, that is the number of my train set, is going to be 0.8. What is 0.8?
80%.
Can I call
80%.
0.8? Can I call 0.8 80%?
Yes.
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 Is 80% 0.8?
Yes, sir.
Yes, sir.
Yeah, so
8
if
out
I
of 10.
multiply, if I multiply 0.8 by my n, what is my n? What is n?
Total number of lengths.
144.
N is the length.
144.
Yeah, n is the total number. Yeah, total number of observations. 144. So I say 0.8 times 144. This floor, it means I am trying to round it up to the nearest whole number. I am rounding it up to whole number. That is why I'm having floor. I'm having this prefix before my parenthesis. So I say hen train, I run that, then I print it. What is my hen train now?
115.
115. So can someone just help us confirm 80% of 114? What is it? 80% of 144 is what?
115.
Yeah, so 80% of 144 is 115, right? So our training data now is going to be the window. This is how we get the
They're not going to do stay.
Are we following? Are we following? Are we following? I'm hearing
Yes.
some
Yes, sir.
side talks.
It's
Okay.
floor function, same as
So
round function.
yeah.
That is
It runs
upper.
our data. Yeah. So train underscore test is our training data set. What is our training data? We remember our TS data. What is our TS data? TS underscore data is what? Do we remember what our
Time
TS
Yes, sir.
underscore data is?
Yes,
I want
sir.
to be sure we
time
are following. Yes,
time
our
series
data
data.
set that we've our
Yeah,
data set that
yes.
we've made time series data set. So what we are now trying to do now is that we are saying our training data set, we want it to end at TS data sets. Then we are using these square brackets. This square bracket now is that we are saying that my training data set should stop at my end train. That what is our end train? If you remember, what is our end train? What is our end train?
That's the
115.
80%.
80% of our
115.
data. Thank you very much. 80% of our data set. So we are saying my train data should end at exactly 80% of my data set. So now, if you see my test data set, you can say I am doing something. I say start. I said it should start from training data set plus 1. That is immediately after the end of my training data set. I want you to start counting my test data set from there. That is why I have n train plus 1. Did we follow up to this point?
Yes, sir.
Yes.
Yes, sir.
Yeah,
Yes.
so n underscore train plus 1, that is immediately after my 80%, you begin to count my test sets. Are we following?
Yes.
Yeah,
Yes, sir.
Yeah.
yes. When Mr. Sampson was training us last week on our models, he was telling us something about ACF and PACF, right? Do we remember?
Yes, sir.
Yeah.
Do
Yes,
we
sir. Yes,
remember I
sir.
was telling us ACF and PACF? Who can tell us what he said about our PACF and our ACF? Can anybody remind us? Our time is really running. Our time is really running. Okay, because of time. What PACF is simply saying is that I want to know how far can I go back in time? Are we following?
Yeah.
How far can I go back in time to project into the future? Are we getting that? That is in my time series. If you want to forecast a weather, now in Nigeria, it is possible for us to predict that it will rain tomorrow because it rained yesterday or it rained 2 days ago, right? Are we following?
We are following. We
Are
are
we
following, sir.
following?
Yes, sir.
Yeah.
Yes,
Can
So
I
sir.
ask a
it is
question?
telling us how far can we go back in time to predict into the future. So this is our AR order in our ARIMA model. What did I call it?
AR order.
AR order. We in ARIMA, we have it to be ARIMA. ARIMA, right?
Yes.
It
Yes.
is we said it is AR is our auto regression, then I is our integrated. That is, then MA is our moving average.
Mm-hmm.
Sorry, please. Can I ask a
Right?
question? Please, sir.
Yes, sir. Go ahead, sir.
Sorry, I may take you back a bit. It's just I
Okay,
need some
sir.
clarification on line 39. When you say
Okay, sir.
converting to time series data, what does it
Yes.
really mean?
Yeah, when I told us something about cleaning our data sets, I was mentioning something that there are some things you need to certify before you can do anything on your data set. That any data set you have no information about or you've not worked on, you shouldn't use it for any analysis. For instance, when you're trying to work on machine learning, we need to be sure that every our data set are numerical sets, right? And I said something that our date and time, our date column or time anything must be in a format called date and time format. So for time series analysis, we must be sure, we must confirm and double check that our data set is in time series format. Are we following? So we are making this TS here. It is that we are changing our data set. We are converting our data set to time series data. Are we following?
Yes.
Okay.
Am I clear now? Am I clear now?
Okay.
Is it clear?
I'm a agent.
Is it clear now?
Please mute.
Is it clear now? Is it clear now?
Well, you can go ahead, sir.
Yes,
Are
sir.
you sure? Are you clear? All right. So remember something. You could remember vividly when we check our ADF, the augmented Dickey-Filler test. Somebody said boldly that something happened to our data sets. What did the person say? The person said something. When we checked our ADF test, the person said our data set is stationary, right?
Yes.
Yes.
Yeah, that our data set is stationary, that we don't need to difference our data set. So now, because our data set has been stationary, is a stationary data set, so what is the value our order high should take?
Order I. Sorry,
The
what's order I?
integrated. Yeah, order high is talking about it is the order which is it is the one joining bringing the AR order and the HEMI. It is the integrated. That is, it talks about what the number of time you difference your data set for it to become stationary to certify the assumption of ARIMA models.
I think it's one.
Are we following?
One.
No, it's not one.
0.
0. Thank you very much. We didn't do anything to our data set, so it is 0. Are we getting it? So now we've
Yes.
explained, we've established what our AR means, what
Can you give
ACF
an
means,
instance
PAC.
where we difference like once or twice?
Yes, once we difference our data set, we are going to be supplying this. Our data set does not need to be different, so there's no point differencing it. If our data set would have if it needed differencing, our p-value here would have given us something like 0.06 or 0.07. If our p-value had given us something about 0.07 or 0.06, we would have needed to difference our data set. But since we have 0.01, it's just like you taking paracetamol when you're having you don't have any symptom of headache. So what's the point of the paracetamol? Do we get? There is no point of taking an analgesic if you don't have pains or anything. Are we following what I'm saying?
Okay.
Are we following? So there is no point differencing our data set since we don't have the need to do that. So now, for our ACF, our HEMI, what we're trying to say, okay, let me just give us an example that we can easily relate with. You know, for instance, you went somewhere and you predicted that, okay, as I'm going to this place, I'm going to be eating 10 biscuits today. I want to eat 10 biscuits today. You've predicted that today I'm eating 10 biscuits. Are we following? Then on getting to the place, you eventually consumed 15. Right? Are we following?
Yes,
Are we
sir.
following? Yeah. So you eventually consumed 15. What has happened? You know, there is an error of 5 because what I predicted was 10, but I'm consuming 15. There is an error of 5 already. Are we getting it?
No.
Yes, sir.
Okay. Yes, let me come again. Like, I am going for a party. I'm going for a party or I'm going for an occasion. I'm going somewhere. Then I've predicted that this place today, I am going to consume just 10 biscuits because I don't want to eat much. I don't want to eat too much of junks and all. I want to eat proper food. But I said today I'm restricting myself to just 10 wraps of biscuits. But on getting to the place I went to, the biscuits were so sweet to the point I didn't know I'd eaten 15 of them. So now there is something that has happened. What has happened? I predicted 10, but I'm eating 15. What is the error that is there? Error of what? 5, right? Yes, 5. So now what ACF does is that it is trying to predict into the future accounting for the error that has happened before.
Okay.
Are we getting what I'm saying?
Yeah.
I am trying to predict into the future, accounting for the error that has happened before. So if I want to predict into the next time now, if I want to predict into the future, what I will say, okay, I said I was going to hit 10, eventually I consumed 15. So now I am not staying with 10 again. What do? I work on the error of what has happened before. Are you
Yeah.
getting what I'm saying? So
Yeah.
now I work on the error because I want to have a better prediction. Do we understand what ACF and PACF is now?
Yes. PSCF is for
Yeah,
is retrospective. ACF is
yeah.
prospective.
No. They are both prospective, but it's just that it is working differently.
Okay.
AR model, that is the PACF, is saying how far can I go back in time, right? To predict into the future.
Okay.
Why my HCF is just saying, yes, I am going back in time, but I am not just going back in time, I am accounting for the error that has happened in time. I said I was going to hit 10, I hit 15 eventually. So now I'm going to account for that error going forward
Okay.
in my
Yeah.
prediction. Are we following?
Yeah.
Yeah. You agree with me that we are humans. We are humans, and when I'm building my model, I'm supposed to supply all of these values. I'm supposed to supply my AR order, my MA order, and my integrated order. Are we getting
Okay.
that? So now that will now give my ARIMA, because in ARIMA model you have something like ARIMA, then in brackets you have your order to be 1, 1, 1, 1. What does this mean? If I say my ARIMA order is 1, 1, 1, what am I trying to say?
The
The
I is
number
What
of
do
1,
I mean?
times.
I is 1, and the
The number of
M
times
is
you're
Thank you very much.
differentiating your data set.
Yes, that is the middle value. So now what I mean is that my AR value, my order AR is 1, my order high is 1, my order MA is also 1. So that is what I'm saying in essence. Are we getting? Our time is running. So
Okay,
now
sir.
we are
Sorry,
humans. Are we getting it?
sorry, please,
We are humans.
Sorry.
We are
Sorry, sir.
humans.
Sorry,
I
can
want
We
you
are
to
take
ask
that
a
one
question.
again?
please,
okay. We are
could you
saying when I want to build a
explain
model,
the
when I want
AR
to build a
and
model,
MA?
We're not
in
hearing
machine
you.
learning, we talked about. Hello, can you hear me?
Now, yes.
Yeah, in
I
machine
want
learning,
to
we
ask a
talk about
question.
things like
Oh God.
hyperparameters. We talk about hyperparameters. Do you remember when
Yes.
Prof was taking us on hyperparameters? So now we say the hyperparameters of this model are this value. So for our ARIMA models, our hyperparameters are A, R, yes, I order, and MA order. Are we getting what I'm saying?
AR, I.
I and MA. Those
Those
are
are
the
my
parameters
hyperparameters.
of our ARIMA model. Those
Could
are
you
the
explain
parameters of our
the
ARIMA model.
parameters?
Yes, sir. Yes, sir.
Please,
What did
could
you
you?
say, sir?
I said, please, sir, could you explain these three parameters, please?
Okay, maybe you went out of the call before I explained everything before, but I'll do that again, just like you said. PACF, when we say PACF, what we're talking about is that how far can we go back in time to project into the future? Are we getting what I'm saying? If I say I am going into the future, I am trying to forecast the weather of tomorrow. It rained 2 days ago. If I'm predicting that it will rain tomorrow based on what happened 2 days ago, I will say my PACF is 2. That is, there is a correlation between what happened 2 days ago and what will happen in the future. Are we following?
Yeah.
Are we following?
Yes.
Yes.
Yeah, so for my high is simply saying the number of time I have difference my data to ensure my data is certifying what my ARIMA model state as its assumption, that my ARIMA model must be stationary. That is, the mean must not change over time. That is, when I check a particular window of my data set, the mean must not change compared to another window of my data set. Did we follow up to that point? So when we say
Yes.
MA, we are saying we are trying to go back in time. Now we are not just doing that alone, but we are trying to give room for the error that has happened. I gave example of the issue of biscuits, that I'm going for a party because I'm trying not to consume as many junks as possible. Then I said I'm going to be consuming 10 wraps of biscuits, but eventually I consume 15. So I have an error lag of 5. So these 5 that we have there, going into the future, I need to consider all of these guys. I need to consider the 5 into my prediction. Are we getting what I'm saying?
Yeah.
Yes.
Yeah. So now there's a way we can automate all of these things you're saying. Like we automate everything there is something we can use to automate all of these processes. Actually, there are plots we need to do. You can make plots to get the value of your ACF, to get the value of your PACF. And I've explained how to get our high for us. Our high is simply the number of times we difference our data set for it to become stationary. So now our PACF, I and ACF. So we can get them automatically using the function auto ARIMA function. This function I've highlighted, auto ARIMA function. But before we go forward, let's see our plot, our decomposition plot. There is something beautiful about our plot that will inform the kind of model we are going to be using. What is that? What do we see about this seasonal, our seasonal decomposition? What do we see there? Is it important?
Yes.
Is our data set
Important.
seasonal?
Yeah.
Yes.
Our data set,
Important.
yes, it is highly seasonal. Okay. So this is where we are going to stop today. So we'll continue in our next class.
Thank you.
Thank you, sir.
It was a nice class. Thank you.
All right.
So we are going to continue in our next class. I think our next class is on Wednesday. So we'll continue. If you check it.
All right. Thank you, Mr. Bakari Dolapo.
Seasonality, seasonality is just like the price of chicken. What time in the year do we have a hike in price of chicken?
Christmas.
Christmas. Okay, good. That is, we have a hike, maybe Easter as well. So we have a hike in the price of chicken every Christmas period. So that is what we are trying to say. So our data set is highly seasonal. Are we following? Our data set is highly seasonal. So we are going to be making use of the auto ARIMA model. Then we are going to be using this scoring metrics. See our information, this scoring metrics is the Akaike information criterion. It is a matrix which we use to score our model. Are we following?
Yes.
Akaike information criterion is an evaluation metric for time series or ARIMA models. So we have the BIC as well, which is the Bayesian information criterion. So these two, we use them. So we supply it that, okay, based on this auto ARIMA, even though I'm automating it, but I'm still trying to I'm still trying to put things in check, because I'm trying to say, yes, my AIC value, you should score my models. You should tell me this is going to be a good model don't just tell me this model is good. If I tell you this product is good, what is the next question you're going to ask me? You ask me why. I should convince you that this product is a very good product. So this is our method of trying to convince ourselves that the automation process trying to convince us that this is the best model or this is a good model. It is by passing it through the information criteria, archaic information criterion. So when we run this code, it is going to generate a lot of SARIMA models for us. So let me start talking SARIMA now, because our data set is seasonal. We are working with the seasonal auto regression integrated moving average. Are we following?
Yes.
Did we follow
Yes,
to
sir.
this point? So yes.
Yes.
So this is what we are going to be stopping today, because our time is actually up. So we are going to be stopping here today. We just have a few things to do. We have very few things. So we are going to continue. We are going to pick it up from here in our next class. So do we have any questions?
All right. Thank you, Mr. Dolapo, for
Yes, ma'am.
the wonderful session. So we have some few questions here.
Okay.
Jacqueline was asking that, do we need to choose those hyperparameter randomly?
Okay. Yeah. Hyperparameters, we can supply them. We can supply them by ourselves. We don't choose them randomly. They are actually plots. This is going to be the assignment I'll be giving to us. Is that we should go and learn more about ACF and PACF. ACF and PACF. So we're going to be seeing what our ACF plots look like and our PACF plots looks like. So you will see from there. And I want you to read how we can pick a correct ACF value and PACF value. But because of all of this stress, we are humans. Like I said, we are not machines, and we are bound to make mistakes. So we are trying to automate all of this process. We want the machine to do everything for us, but we are still supervising it because we are not just taking everything it's giving us blindly. We are still going to be supervising all of it. So we can, yes, we can supply it randomly. It's not randomly. It is not going to be a random selection. They are actually plots. They are ACF plot and PACF plot where we can pick what our actual ACF plots, ACF values and our PACF values. However, we can still do something we can do it by making it automatic. That is, the auto ARIMA function is going to supply all of these things for us. Our ACF, our PACF is going to be supplied for us. We don't need to go through the stress of trying to plot our ACF or our PACF. So yes,
All right.
that's the answer to that.
So thank you for the answer. I hope the person that asked is okay with the response. So there's another
Yeah.
question here. Says, sir, when we talk about log, is it natural log when we log transform our data? I think this person is a
Yes.
mathematician.
Yes.
Okay, there is actually a comment here too saying, sir, we do not accept the null hypothesis, we only fail to reject. So I think that's a comment.
Yeah. Yes. Thank you very much. Yes, my attention was called to that. Actually, I know that is the best practice, but then I was thinking of trying not to confuse people because that brother or that person is probably a statistician and he understands this thing. But yes, that is the best practice. So saying we accept the null hypothesis, yes, it is.
Yeah,
We
there's
fail
still
to
another question
accept it.
All right, there's another question by Zaid. So what is the essence
right.
of using a log transformation in line 37 of the code now, in line 37? What is the essence
Okay.
of log transformation? When
All
and
right.
why should we use it?
Okay. In the beginning of the script, I wrote something there that these are the core assumptions of our ARIMA model. Then we say something that the mean, the variance, and the autocorrelation must not change, do not change over time. That is, I explained very well that when we pick a particular window of our data set, when we check the mean, we check the variance, it must not change from the value of another window of our data set. So the reason why we log transform is to make sure our variance does not change over time. That is, our variance in each window of our data set is constant. We want to make our variance to be constant. So that is why we log transform. That is the essence of log transforming our data set.
Okay, so the person is now asking that should we be using it all the times? Because why should we use it? When and why should we use it? Must it be anytime we are working with time series data, must we log transform the data?
Yes, it is better to log transform our data set, but if you have checked yourself that the variance of your data set does not change over time, then you don't need to log transform. Why wash a clean clothes? So we don't need to log transform if our data set the variance of our data set does not change.
All right. So the second question says, how do we carry out differencing, and at what point we do that?
Okay, when we want to difference our data set, I mentioned something. That's the essence of the whole augmented Dickey-Filler test. That is, we are trying to check to know if our data set is stationary. So number one is certifying the variance issue. Then number two, the difference is going to be satisfying the mean. So we need to be sure that our mean does not change. So how do we do it? There's a function in R, the diff. We can see this diff. This diff will help us to transform our data sets. So our X is going to be our data set, then comma the number of times we want to difference it. So that will do it for us easily. So I mentioned that if you do it once and it is not still stationary, what do you do again? You do it once again until it is stationary. So that is just it. But your data must be stationary before you can carry out a time series analysis.
All right. Thank you, Mr. Bakare Dolapo. So I don't know if we still have question. Our participant, if you have a question, please kindly raise up your hand. All right. Kindly raise up. Kindly unmute yourself and ask your question.
Yeah, Uche, you can go on with your question.
Yeah, thank you very much for your class. I
Yes, sir.
honestly enjoyed it. I honestly enjoyed it very well. But
All right, sir. Thank you, sir.
I want to know if you can help us do with what Professor Tron did for us in machine learning. He just gave us the
Okay.
steps to follow while dealing with time series data. It will go a long way to helping us.
The steps.
Yes, the steps to follow
Yes,
while work.
Okay, the workflow.
Yes, the workflow.
Okay, the
Yes,
workflow.
sir.
Okay.
Yeah.
But this code actually is systematic. It's systematic, so I don't. But I'll just give us the workflow. I'll give us the
At least
workflow. No
it will
problem.
assist.
I'm not sure I'm getting your question.
Okay,
I'm not sure
let
I'm
me
getting your
just let
question.
me. Okay, can you hear me?
All right. Go ahead. I can hear you.
Okay, so I think what he's trying to ask is if you can, Professor Chong was using a notebook that contained text. Like all the expressions you're doing with mouth, they also have it as a text, and then before they now run the code. So in that case, now probably you need to create a markdown where you explain, give explanation of each of the steps before they now run the code. So I think that's what he's trying to ask.
Okay, all right. That will not be an issue. That will not be an issue. I will do that, and I'll make sure the next class is that way. So I'll design the next script to fulfill that course.
What about this one?
Yes,
Sir?
class.
Ma?
What about this?
The notes, like,
Let's
Can we
free him.
also get this?
Let's free him for this one. Let's free him for this one.
This one is on the group already. I shared this on the group. I shared this particular script on the group.
I'm sure the video the what's it called? This stream is being recorded. We just watch it over and over again and master the skills.
Yes, it's being recorded on YouTube. So
I beg.
All
it's
right.
on our
Thank
YouTube
you,
page.
Mr. Dolapo. Do we
Yes,
still
ma'am.
have any question from the participants? Okay, so since we are streaming online now, like the whole thing is going virtual, I will employ everybody to pay a very close attention to any information drop on the group, because this R script has been sent on the group and reminder has been sent so many times. So please let's follow instructions strictly, and then when it comes to hands-on, let's try and follow the facilitator by opening down our R script and then learn along. So I really want to appreciate every one of us that participated in today's learning. So we hope that we also come on time tomorrow so that we can cover to a large extent. So I wouldn't know if there is any information or any announcement that we need to be passed across to the house.
Yeah.